In this video, we're going to look at a precipitation reaction. We've got two solutions, calcium chloride and silver nitrate. And it might be a good idea just to pause the video here for a second and try to make some sense of the first part of this, which I've already written down. Our goal is to find the concentration of all the ions remaining in solution after we mix our calcium chloride with our silver nitrate. Uh, First, I want to find moles of everything, moles of all the ions. To start with, I've got the molarity of the calcium chloride. I want to know the molarity of the individual ions so that I can use that to find moles. Well, if calcium chloride is 1.5 molar, calcium is 1.5 molar as well. The chloride, however, there's two of them per compound, so the concentration of the chloride would be 3 molar. And the silver nitrate is a little easier. It's all a 1-to-1 ratio. So now that I've got the concentrations of all the ions, I multiply them by their respective volumes to get the number of moles, which I've laid out here. The net ionic equation is silver plus chloride yields silver chloride solid. You can get that from the table you've been given to predict the precipitate. Moles before, we've calculated this. We'll just pencil it in. So for silver, it was 0.030 moles. And for the chloride, it was 0.15 moles. For the calcium, 0.075, and for the nitrate, 0.030. Moles after, we're looking at our net ionic equation between silver and chloride. We can see that silver is limiting. We have far less silver than chloride. So all of the silver will be used up. The volume is the same for all of these. It's just that the two volumes added together, 50 milliliters and 30 milliliters, makes 80 milliliters. So the concentration for this one is 0. In the case of chloride, we've got our starting number of moles, and then we have to subtract the number of moles that would have reacted with the silver. Because it's a 1-to-1 ratio up here, 0.03 moles of chloride must have reacted with 0.03 moles of silver, which leaves us with 0.12 moles of chloride remaining, unreacted. The volume is the same, and it's the same for all of these, so I may as well write that all in now. The calcium and the nitrate are spectator ions, so they are not reacting. The moles after will be exactly the same as the moles before. And now to find the final concentration of all of these, it's just division. Moles divided by volume. Chloride ends up being 1.5 molar, calcium 0.94 molar. And you should check with your calculator to make sure that you're getting the same values.